Hello students, welcome to the class. Now we are going to deal today with some important derivations regarding spherical mirrors, and we'll begin with a relation which is f equals to r by 2. Relation between focal length and radius of curvature. Focal length f, radius of curvature r. Okay, so we are going to deal with the relation. What? It is a relation between focal length f equals to r by 2. We have to derive this relation. Okay. Now, there is a very simple job. How can you obtain it? For that, we take what? A concave mirror. Okay. And suppose it is the pole and center of curvature, and here's the focus. Okay. And suppose a ray is incident on the mirror at a point M. Okay, we have a ray incident parallel on the mirror M. When the ray is incident parallel, the parallel ray would pass through what? Focus. So this ray after reflection would pass through the focus. Now if I just join the center of curvature with the point M, which is the point of incidence, you will get this as normal at this point M. As the point M, this is what? Normal. And when it is normal, whatever is the angle of incidence, the same will be the angle of reflection. So, angle of incidence equals to angle of reflection equals to theta. Okay? Now here, you can go through some more geometrical concepts. As this angle is theta, this will be also theta. Means angle MCP will be equal to what? Theta. Are you getting it? This angle and this angle. Okay, these rays parallel to principal axis. So alternate angles. This will be equal. Okay. Also, if you think of this angle, what will this angle? This angle is exterior angle to these two angles, this triangle. For this triangle, it is exterior angle, and when it is exterior angle, it should be what? Theta plus theta must be equal to what? 2 theta. So very well, angle MFP will be equal to what? 2 theta. Are you getting it there? Okay. So here you have the angle theta and theta equal, because angle of incidence equals to angle of reflection. This is theta, so this will be also theta. Alternate angle, and this angle, which is the exterior angle, will be the sum of opposite interior angles. So theta plus theta equals to 2 theta. Now after that, if I drop a perpendicular MD, one thing I just wanted to remind you, that is what we exactly follow NCERT book while dealing with the concepts and derivation. Okay, so for that you may refer NCERT part 2 book, page number 312, 313, 314. Today we, in this lecture, will go through these all pages. Okay, so you can go through page number 312. You will get this all concept there. Okay, so here if I drop a perpendicular, so MD is perpendicular on what? CP Is that clear? Now after that, what I define? Tan theta in triangle MDC. If I define tan theta will be equal to what? MD upon CD. MD upon CD. In this triangle, tan theta will be equal to what? MD upon CD. In the same way, in triangle MDF, check the triangle MDF. In this triangle, tan 2 theta will be equal to what? MD upon FD. Tan 2 theta will be equal to what? MD upon FD. Now, very important thing, if you think of the mirror and reflection phenomena, generally what we do, we deal with a mirror with what? Small aperture. We take generally the mirror of a small aperture and we take the rays incident paraxial. Paraxial means the rays will be very near to the principal axis. Means we consider this aperture very small, and when you take the aperture very small, this theta and 2 theta will be very, very small. Okay, so for paraxial rays, tan theta will be nearly equal to theta, and tan 2 theta will be also. Why? Because theta is small. Because theta is what? Small. So as theta is what? Very small. Are you getting it? Theta is very small for paraxial rays. So you got it? So when theta is very small, you may write tan theta equals to theta and tan 2 theta equals to 2 theta. So you will write this as what? Theta equals to MD upon CD, and 2 theta equals to MD upon FD. Have you heard this? Now, if I combine these two relations, what will you get here? 2 theta is what? MD by CD equals to, I put here the value of theta in this equation, second equation. So it is theta MD by CD equals to MD by FD. From here, MD cancels out, and what will you get? You will get FD equals to CD by 2. FD equals to what? CD by 2. Now, for very, very small mirror, the mirror of a small aperture, D will be very close to P. And when this D will be very close to P, the FD may be written as what? FP or PF. CD may be written as CP or PC. So here you may write FD as what? FD as what? PF. You may write. Because D and P are very close. So FD can be written as what? PF. In the same way, CD can be written as what? PC. So CD will be what? PC by what? 2. Because these two are very, very near. This, for a small aperture, D will be very close to what? P. Is that clear? And from here, now when you have the sign conventions, okay, lastly, when you have the sign conventions, PF this way, opposite to the incident ray. So PF will be equal to minus F. So from sign convention, okay, in the same way, what will be PC? Minus R, opposite to the ray. and when I put these values there, what will get? F minus F here, and here minus R by 2, which will give you what finally? F equals to R by 2. So you got the relation. Okay, so an easy job to obtain it. You can very easily obtain it. Again, repeating what you have taken there: incidence ray. Okay, incident on a mirror at the point M. Point is that M is what? The point of incidence. And when the ray is incident parallel, it will be reflected through focus. Okay. Now, if I join a line from C to the point of incidence M, this Cm will be what? The normal at this point, because radius is always normal. And when it is normal, if this is theta, the angle of incidence, this will be also the theta. The angle of incidence must be equal to angle of reflection. Okay. Also, this angle is theta, this will be also theta, because these two are what? Alternate angles. So this angle MCP will be what? Theta. In the same way, if I think of this angle MFP, this will be 2 theta. MFP will be what? 2 theta. Why? Because this is what? Exterior angle. Okay. After that, if I drop a perpendicular MD, and if I define tan theta will be what? MD upon CD. Likewise, in this triangle MDF, if I define tan 2 theta will be what? MD upon FD. That we have written. Tan theta, MD by CD. MD by CD is tan theta. MD by FD. MD by FD is tan 2 theta. Now, when we think of mirror, the first assumption is what? We always take the aperture small. And when you take the aperture small, what will happen? These rays will be drawn very near to the axis. To make it very clear, actually we are taking somewhere here, but generally we choose the rays to be incident very near to the axis. And those rays which are incident very near to the axis are called what? Paraxial rays. And for paraxial rays, the theta, okay, the M will lie somewhere here. So theta will be very small. So theta is small, 2 theta is small. So you will write tan theta equals to theta. Tan 2 theta equals to what? 2 theta. And this relation will become what? Theta equals to MD by CD. This will become what? 2 theta equals to MD by FD. Now from here, if I just put the value of theta somewhere here, in this equation, we'll write twice of, in place of theta, MD by CD. Okay. Now MD FD cancels out. You'll get FD this way, FD here, FD will be equal to CD by 2. Now, as D and P will be very near, you will write there FD will be equal to FP or PF. Okay, FD will be FP or PF. In the same way, CD will be CP or PC. That I have taken, we have taken D very near to what? P. D and P are very near. Okay, and after that, you got the relation like this. In this relation, what is PF? When you put the value, numerical value, while we put the numerical value or any substitution, we take the sign convention. So when we take PF, its value, the focal length, it is nothing but focal length. So it is what opposite to the incidence ray. So minus F. PC, the radius of curvature, opposite to the incidence ray. So minus R. That we have taken. And when you put this as minus F, minus R by 2, you will get this. And finally, F equals to what? R by 2. This is the first derivation we need to deal in this spherical mirror part. After that, we'll move to next derivation, which is the mirror equation. That is also very, very important. Okay. So after that, next we'll deal with what? The mirror equation. Okay. So here in the mirror equation, we'll take a concave mirror with the center of curvature C, pole P, and its focus F. Okay. So mirror equation. So let us take a concave mirror. Okay. Is it not sync? I should write something. here below mirror equation. Okay, mirror equation. What is that mirror equation? So for that we take what? A concave mirror. Again, okay, P is the pole, and here is the center of curvature, and here is the focus. We have derived that focus will lie just within what? In between the pole, and because if this is R, this is F, then F must be R by 2. अभी हमने देखा, ठीक है? So ये F है, ये R है, तो फोकस को P और C के बीच में होना चाहिए, because F equals to R by 2. Okay, so we have taken here the focus. Now, if I take an object beyond C, here is an object A, B, okay, and that object we have taken beyond C, between C and infinity, and suppose a ray is incident on this mirror, okay, ray is incident on this mirror at the point M. What will happen? The ray after reflection should pass through the focus, okay, because this ray is incident parallel to the principal axis, so by the rule it should pass through the focus. Secondly, a ray which is incidence along the direction of center of curvature, okay, I have to extend this mirror somewhere here. If a ray is incidence along the direction of center of curvature, it should retrace its path, because it is just incident normally. The line through the center is always normal to the mirror, so it is incidence normally, so it will retrace its path. Also, a ray which is incidence at P at certain angle theta will be reflecting at the same angle theta. Okay, a ray which is incident at this point P at certain angle I will be reflecting at the same angle I, because CP is normal here. Okay, a line from C is always normal, so CP is normal there, so I and I at the same inclination it will reflect. Now these all rays which are starting from the head of this object are meeting here, so here the head would be formed. So here is the image form A dash B dash. You got the point? So here in this way you can form the images. Okay, so what do you find there? When the object is kept beyond C, the image is real, inverted and found in between what? C and F. C और F के बीच बन रहा है, आप देख रहे हैं यहाँ पे. Now here, if you want to derive this relation, we'll deal with some pair of what? Similar triangle. Okay, तो चलिए देखें कुछ हम similar triangle. You can see here triangle A dash B dash P. Okay, check it. This triangle A dash B dash P. This triangle will be similar to triangle ABP. Okay, ABP. क्यों similar होंगे दोनों? जरा देखेंगे. This triangle A dash B dash P will be similar to ABP. Why? Because this is I, this is also I. This angle is 90 degree, this angle is also 90 degree. दो angle अगर equal हो गए तो triangle क्या हो जाते हैं? Similar. आप समझ रहे हैं? So here the triangle A dash B dash P is similar to ABP. So from here you may write what? A dash B dash upon AB. Okay? A dash B dash upon AB must be equal to PB dash upon PB. Okay, A dash B dash upon AB, the corresponding side, the ratios must be same. PB dash upon PB. Okay. Also here, if you see the triangle MPF is similar to triangle what? A dash B dash F. You can see the two triangles here. We generally take, as these rays will be very near, this will be almost straight. We take MP as a straight line. Okay, we choose what, this MP to be a straight line. So from here, MPF, this triangle will be similar to this triangle, A dash B dash F. These two angles are equal. This is 90 degree. This also be taken as what? 90 degree. Okay, because we, for paraxial rays, we may take this as a straight MP. So here this triangle MPF is similar to what? A dash B dash F. So you may write what? A dash B dash upon MP. Okay, A dash B dash upon MP as what? B dash F upon PF. B dash F upon PF. Are you getting it? So these two triangles are similar. This triangle and this triangle. So A dash B dash upon MP must be equal to B dash F upon PF. Now here, as this MP and AB are equal, I can substitute what? This MP as what? AB. Are you getting it there? You may write MP as what? AB. So you may write this MP as AB, the two are equal. Now, if you think of these two equations, you will find that these two equations have the same left-hand side. So from equation 1 and 2, the right-hand side also should be equal. So PB dash upon PB, left-hand side, is this same, right-hand side, here right-hand side. Okay. Now further, here this B dash F, as we measure all the distances from pole, therefore better to write B dash F as what? PB dash minus PF. B dash F can be written as what? PB dash minus PF. PB dash minus PF upon PF. So in place of B dash F, you may write P B dash minus PF. Now after that, if I use the sign convention and put the values PB dash, image distance opposite to the incidence ray, minus V. Okay, it will be minus V. PB dash, ray ke opposite, minus V. Then here PB, object distance, ray ke opposite, minus U. Then PB dash again minus V. Then PF minus F. Okay. Then here PF minus F. Minus plus cancel हो जाएगा, V by U. This will be what? Minus V plus F upon minus F. If I have a cross multiplication, what will get there? VF, this side minus VU minus UF. Okay, are you getting it there? So when you have cross multiplication, minus VF minus UV, and it will be plus UF, U into F. Okay, now divide the whole equation by UVF. UVF. When you divide the whole equation by UVF, what will get there? V and F will cancel out. Minus 1 by U. V and U will cancel. Minus 1 by F. And it is what? U and F will cancel out. U and F. So 1 by V. When I take this F this side, 1 by F equals to U, 1 by U this side, 1 by V plus 1 by U, which is nothing but what? The mirror equation. So in that way, are you getting it? You can obtain the mirror equation. Are you getting it there? You can obtain the mirror equation here. So repeating it very quickly. Okay. So you have a concave mirror. Concave mirror on which, in front of which you have taken an object AB beyond C, between infinity and C. Okay, a ray which is taken parallel, incident parallel at M will pass through what? Focus. A ray which is incident along the center of curvature, it would retrace the path. And a ray which is incident at P at certain angle I would be reflecting at the same angle I. Okay, as all these three rays which are starting from the point A से निकल के वो यहाँ मिल रही है, इसलिए A का जो इमेज है यहाँ बनेगा A dash. So A dash B dash is what? The image. अगर हमको मिरर इक्वेशन निकालना है तो क्या करना पड़ेगा? चलिए हम दो ट्रायंगल्स जो है उनकी सिमिलरिटी पे फोकस करेंगे. हमारा की कॉन्सेप्ट यहाँ पे क्या है? वहां पे हमने थीटा और टू थीटा डिफाइन किया था. हर एक देखिए डेरिवेशन फिजिक्स में करना बहुत इजी होता है. आपको केवल की कॉन्सेप्ट पता होना चाहिए था. मैंने वहां पे थीटा और टू थीटा पे फोकस किया था पिछले रिलेशन में. मुझको इस रिलेशन में केवल दो सिमिलर ट्रायंगल के पेयर में कंपेयर वो जस्ट ध्यान देना है. ये ट्रिक है. हर एक डेरिवेशन फिजिक्स में एक छोटे से की कॉन्सेप्ट पे बेस्ड होता है. ठीक है, तो की कॉन्सेप्ट क्या है ध्यान से समझ लीजिए. यहां पर की कॉन्सेप्ट है पेयर ऑफ व्हाट? सिमिलर ट्रायंगल्स, टू पेयर्स. पहला पेयर कहां से? पी से बनेगा. ए बी पी is similar to A dash B dash P. दूसरा पेयर F से बनेगा. हमेशा P और F से बनता है. याद रहेगा सबको? P और F. और यही चीज लेंस में भी होगा. लेंस में भी दो सिमिलर ट्रायंगल जब आप लेंस का फॉर्मूला ड्राइव करेंगे. सो की कॉन्सेप्ट सेम होता है. सो यहां पर की कॉन्सेप्ट क्या बोलता है कि आपको दो पेयर देखना है सिमिलर ट्रायंगल के. कौन से दो पेयर? A B P is similar to A dash B dash P. So from here A dash B dash upon AB will be equal to P B dash upon PB. ये पैरेलल रिलेशन है. Okay. In the same way, आप देखिए दूसरा सिमिलर ट्रायंगल का पेयर MPBF. MPF is similar to A dash B dash F. तो A dash B dash upon MP. Okay. जो A dash B dash upon MP होगा वो A dash B dash upon MP will be equal to what? PF. Sorry, B dash F upon PF. A dash B dash upon MP will be what? B dash F upon PF. B dash F upon PF. अब देखिए MP जो की है वो AB के बराबर होगा. तो इन दोनों का लेफ्ट हैंड साइड क्या हो जाएगा? सेम हो जाएगा. तो राइट हैंड साइड क्या हो जाएगा? इक्वेट हो जाएगा. देखिए P B dash upon PB is B dash upon PF. अब इसमें मुझे हर चीज ठीक लग रही है. हर चीज P से चालू हो रही है. एक चीज पर गड़बड़ है. B dash F. ये हमेशा आपको P से ही मेजर करना है. All the distances are measured from what pole. So मैं B dash F मुझे पसंद नहीं आ रहा है. B dash F को मैं क्या करूंगा? मैं इसको जो है कहां से मेजर करूंगा? पोल से मेजर करूंगा. So P B dash minus PF हो जाएगा B dash F. P B dash minus PF will be B dash F. तो ये लिख दिया मैंने. अब हम साइन कन्वेंशन रखेंगे जहां पर जो है P B dash है. P B dash रे के ऑपोजिट माइनस V. PB minus U, PF minus F, सब माइनस है. सो रखें वैल्यू PB dash minus V, PB minus U, PB dash minus V, PF minus F, PF minus F. ये आने के बाद क्रॉस मल्टीप्लिकेशन कीजिए, U भी F से डिवाइड कर दीजिए, आपको रिलेशन मिल जाएगा. Have the cross multiplication divided by UVF, you will get the relation. Okay, so ये हम एक बहुत इंपॉर्टेंट चीज देख चुके हैं. क्या? The second derivation, mirror equation. इसके बाद लास्ट एक हम चीज देखेंगे जल्दी से. That is what? Magnification. Magnification. What is magnification? Magnification is a quantity which deals with the size of image and size of object. We define the magnification magnification m as what? Size of image upon size of object. That is what we'll write this m as what? I by o. We choose I as the image size, o as the object size. इसको डिराइव करना बहुत ही सिंपल है. कैसे डिराइव करेंगे देखिए ध्यान से आप. यस, सिंपल जॉब. फिर से देखिए यहां पर ट्राइंगल a dash b dash p is similar to triangle a b p. Same a dash b dash a dash b dash p is similar to a b p. इसलिए मैं लिख सकता हूं क्या? a dash b dash upon a b. अभी देखा आपने सेम चीज. a dash b dash upon a b must be equal to what? p b dash upon p b. Okay, you got the point? ठीक है. So a dash b dash upon a b must be equal to p b dash upon p b. अब वैल्यू रख देते हैं. अब यहां से जो है वैल्यू रखते हैं. a dash b dash उल्टा है इमेज, प्रिंसिपल एक्सिस के नीचे माइनस i. प्रिंसिपल एक्सिस के नीचे मेजर कर रहे हैं इमेज की लेंथ. ओके, माइनस i. ये ऊपर मेजर होगा प्लस o. ऑपोजिट द रे माइनस v. इमेज डिस्टेंस यहां से यहां तक इमेज डिस्टेंस है. ये इमेज है आपका माइनस v और pb माइनस u ऑब्जेक्ट डिस्टेंस. सो माइनस v अपॉन माइनस u. इसको सॉल्व करेंगे तो आपको मिलेगा m इक्वल्स टू व्हाट? व्हाट विल गेट? m इक्वल्स टू i बाय o नेगेटिव नेगेटिव कैंसिल हो जाएगा. इस नेगेटिव इधर दे दीजिए तो i बाय o इक्वल्स टू हो जाएगा माइनस v बाय u. ये आपका मैग्निफिकेशन आ गया. ओके, m इक्वल्स टू i बाय o माइनस v बाय u. अब इसमें और बहुत सारी चीजें देखी जा सकती. कैसे? जैसे मिरर इक्वेशन लगाते हैं. फ्रॉम मिरर इक्वेशन. आपको मिरर इक्वेशन क्या